Hello, let's build a blockchain in lightning quick speed. The idea is to give you hands-on experience with coding a blockchain right away, as soon as the first coding video. So as a disclaimer, this video is not going to be an introduction to Python. The Python intro is the subject of the next section of the course. So if you'd rather go through that material and come back to this lightning blockchain video, then feel free to do so. Or you can view this video as both a preview of the blockchain and Python code. With that being said, let's get started. In order to code a blockchain, we'll need an environment to write our code. A great option is an online code editor. So head to repl.it/@davidjoseph3/python-starter. And to see how this works, let's go ahead and add a print statement of hello blockchain. So as soon as you type into the editor, you're going to find your own instance of the starter file is created. So go ahead and type in print, and then for the value going into the print statement, have a string within single quotes that says hello blockchain. Once you have that, go ahead and click the run button, and you should find in the output a string of hello blockchain. Very cool. Now that we know how this REPL editor is going to work, let's go ahead and code a blockchain. Fundamentally, a blockchain is a list of linked blocks. Each new block in the chain contains a link to the last block that came before it. That's why it's called a blockchain. It's a chain of linked blocks. So to start, the most basic building block is, well, a block. So let's go ahead and create a Python class with a capital B block and have a colon at the end. Again, the first section of the course is going to be a full intro to Python. So if you don't know what a Python class is yet, don't worry. There's going to be a whole video devoted to explaining this concept. Now that we have this block class, we can define its init method. So have the def keyword, and then init is a special one that is surrounded by double underscores, and give it a pair of parentheses as well and a colon. In Python, methods in a class start with a special self parameter, so have self, and beyond that, a block is going to have three main incoming attributes: a data field, a hash, as well as a last underscore hash. I'm going to go ahead and expand this so it fits on one line, and make sure to have an init method with all the parameters like so. Within the init method, we'll set fields for the instance of the block that match each one of these incoming arguments. So self.data equals data, self.hash is going to be equal to hash, and finally self.last underscore hash is going to be equal to the incoming last hash value. This makes it so that when we create a new block instance, we can specify a data hash and a last hash field, and then matching fields for each incoming piece will be attached to the new block instance. For example, we can go ahead and create a block instance by using the block keyword, so make sure it's a capital B and have a pair of parentheses, and pass in foo data as the data argument. For the hash argument, how about foo underscore hash? So all of these are going to be strings. And the last one is foo underscore last underscore hash. And we're going to go ahead and set this to a variable called foo block. So have foo block equals the entire block instance. Okay. Now foo block is an instance of the block class. A helpful analogy here for the class and instance relationship is that foo block as an instance is like a custom object based on the block class, which is like the object template. In this case, the foo block custom object has foo data as its data field, and foo hash as its hash field, and foo last hash as its last hash field. For example, we can print the foo block.data, and what we get is that the value is foo underscore data. And we can do this for all of its fields. So foo block.hash as well as foo block.last hash. So go ahead and have that code and then click run, and nice. Those are the fields that we passed into the block instance. All right, so that covers creating the block class. The next question is, well, what do these fields even mean in relationship to the overall blockchain? Well, primarily the block acts as a storage unit. Therefore, the data field specifies what the block is storing. Second, there's the hash field. The hash is a unique value generated for the block based on all of the block's data. In order to properly generate the hash, you need a cryptographic hashing function. The key behind one of these hashing functions is that it consistently creates a unique value for any different data input, even if that data field is different than what it was before. The main reason a hash is needed is so that the block can become official. Later on, other individuals will want to verify that the block data is correct by checking that the hash can be created using all the data that is presented in the block. Like the other concepts that have already been introduced in this video, there's going to be a separate video later on in the course dedicated to exploring the concept of hashing a lot more deeply. Finally, the last hash creates the link between blocks in the blockchain. By having a field that is set to the hash of the block that came before, a link is created between the new block and the last one. Alright, this completes the block class. Our next goal is to make a blockchain class. But a prerequisite is to create a hash function, like the one we just talked about. At the top of the file, go ahead and define a function called lightning_hash. The hash function is going to take one argument, a data field, and the idea is to generate a unique hash value for whatever data comes in. For this Lightning blockchain version, let's do something quick. The Lightning hash will only add a suffix of 1 star to the data as its hash, so return the data plus an asterisk as the return value. Cool. It's a very basic hash, but it gets the job done in terms of consistently generating a unique value for every unique data input. When it comes to the hash in the actual full blockchain project, we're going to use a much more advanced cryptographic hash function. The hash that it generates is going to look like a random set of characters. Most importantly, it's going to be a one-way hash, meaning it's going to be virtually impossible to figure out the original data by looking at the resulting hash value. This Lightning hash is definitely not a one-way hash. It's pretty easy to figure out what the original data input was. You remove the star at the end. But this Lightning hash does have the ability to generate the same unique value for every unique input, which is one of the most important properties about a true hash function. Okay, with this method available, we can make the blockchain class. Go ahead and delete all the experimentation code we have around foo_block, and then declare a class called blockchain. So make sure it's a capital B and have the colon at the end. We're going to provide an init method, and the one argument it will have is the special self parameter. For now, we're going to set one field in the blockchain called its chain, and this is going to be an empty list, which is created with a pair of brackets. The idea is that the blockchain will create a list of block objects that's held in this chain list. Every new block will be based on a prior block. But this begs a question. What about the very first block in the chain? How does the blockchain create that block if there's no prior one to base off of? To address this, the blockchain starts with a genesis block. It's an initial hard-coded block created purely to allow the first real added new block to have a prior block to reference. In this blockchain, in the init method, let's go ahead and create a variable called genesis, and then this is going to be set to a block instance. For the data field, let's have gen_data. For the hash, gen_hash, and to match the pattern, gen_last hash. Cool. And now we can have the chain list start with the genesis block right away. This allows us to now create a generic add block method that will allow us to add new blocks to an instance of this blockchain class. So define a method of add_block. Let's give it the special self parameter as well as a data argument. Don't forget the colon at the end either. The idea of this method is to take the data, get the last hash value by looking at the last block in the chain, and then create a new hash to make a new block instance that is added to the chain. Now we already have the data as an argument to the method, so next we need the last hash. The last hash value is found by looking at whatever is the last block in the chain, which we can find by doing self.chain, and then to access an item in a list, you use bracket syntax, and the very last item is accessible with a -1. So this gives you the final item of a list in Python. Let's go ahead and set hash argument because we're going to find that very last block and access its hash value. Cool. Now that we have the data and the last hash, finally we need the hash for a new block instance. This should be created by inputting both the data and the last hash field into the Lightning hash method. So let's go ahead and make a hash value that is equal to calling the lightning hash method, and then we're going to pass in the data plus the last hash as a combination. By combining both the data and the last hash, we killed two birds with one stone and ensure that the block hash enforces that both the data and the last hash field have not been tampered with in the block. In other words, for the block instance to be official and valid, the hash must be found by using the fields that are actually present in the block. Finally, let's create a block variable that is equal to a block instance where we pass in the data, the hash, as well as the last hash. And to make sure that this block is added to the chain list, we're going to call self.chain.append, and we're going to pass in the block. Okay, awesome. So that completes the overall blockchain class. Let's go ahead and check it out with experimentation code at the bottom of the file. Go ahead and make a blockchain instance that is set to a variable of foo_blockchain. For the blockchain instance, don't forget to use a capital B as well as a pair of parentheses. Let's have a few lines where we add a block. So first, let's call foo_blockchain.addBlock, and we'll pass in the data of a string where the data is 1. Let's do it one more time, except this time the data is going to be the string 2, and finally the string 3. So make sure to have the 3 foo_blockchain.addBlock lines. Then to debug this, it'd be nice to print out every block in this foo_blockchain chain list. To go through every block, let's write a for loop that steps through the blockchain chain one block at a time. So for block in foo_blockchain.chain, we're going to do something to debug the actual block. It'd be nice to print every attribute of the block like we did before, so its data, its hash, and its last hash field. However, rather than writing 3 separate lines, we can print out the block's dictionary representation instead. This turns a block into a key value collection of its attributes, and to get that, we can use block.__dict__. And to print this, well, we put it in the print method. So again, this special __dict___ method is going to create a key value collection of all the block's attributes. Go ahead and run this, and what you should find is 3 lines for blockchain code. Go ahead and run again to make sure that it's printed nicely on big lines, and check it out. The output that we get is a chain of blocks. So first you get the hard-coded Genesis block with the gen data, but you'll notice that the last hash of the next block references the gen hash. Likewise, if you go to the next block, the last hash references the hash that is found in the block before. So there's definitely a linking of blocks going on in this chain. Very cool. That wraps up the Lightning version of the blockchain. In the course, we're going to build a much more advanced and detailed version of this with far more features. Not to mention, there's a whole idea of the cryptocurrency to start exploring. But this already provides a few fundamental concepts for coding the blockchain. Block units storing data, unique hash values, and last hash references. The next section is going to be a more thorough introduction to Python. However, if you already feel comfortable with the syntax and concepts that appeared in this video, you might want to skip to the section after, where we'll start building the full version of this blockchain and cryptocurrency project.